Picture this. You're working on your program and you're dealing with object creation. There's one problem. No matter what code you implement, you just can't create a flexible and reusable code base. You always end up with dirty and coupled code. But today, you can change that. This is the first video of my design pattern series, where I will cover the 5 creational design patterns to create reusable code for your object creation. Creational design patterns, as I said in the intro, is focused on creating reusable and flexible code for object creation. The first pattern out of the 5 is the factory method. The factory method involves having an interface or abstract class to create objects and letting subclasses choose what object is made. This makes code more flexible by making the object creation process a function. Applying the factory pattern involves 4 steps. First, create the product interface for the products that will be created. Then, you apply the interface to the classes, which are the concrete products. Afterwards, you will create a creator or factory interface that will define the factory method. Finally, using the factory interface, create a concrete factories that create their respective products. Let's see this in action for the example. We're using the toy gun example for the principles video. Let's say that instead of a store, our setting is in a factory that is creating guns to be shipped off to stores. We have the same gun types from last time: ammo, buff, and carbon. An average programmer would probably do something like this. They would define a variable holding the gun to be made, and then check for the type of the gun to choose the method to run. This is bad, because not only is this code tightly coupled, which you don't know basically means reliant, but if you have seen a principles video, you would know that this violates the OCP. This is because when you want to add a new gun to this, you would have to also modify the if statement. Let's apply the factory method to improve this code. For the first step, you will create a product interface, toy gun. Remembering that interfaces are abstract classes in Python. Next, in step 2, you will create the products, ammo, and buff guns. They don't need to have methods yet. Afterwards, in step 3, we'll make the factory interface, toy gun factory, responsible for the creation of guns. Finally, we will make concrete factories for each gun type. Now we can use the factories like so. This pattern is similar to the factory method, but now there are primary factories that create secondary factories that create products. Let's say that the 3 companies behind the aforementioned toy guns collaborate and sell a bundle with the ammo, buff, and carbon guns to form an ABC pack. But there's also a rival trio teaming up as well, having another bundle of guns of D-Bird, Eagle, and Phil guns, forming the DEF pack. Now, when a customer buys a pack, they obviously want each item of the pack and correct. If one were to hardcode each pack, with 2 it won't be bad, but with multiple toy guns, especially for bigger stores, it'll be a big hassle. The steps for this pattern are basically the same as the last pattern, but with some differences and with factories being done before products, or the other way around. Now let's fix this code. Step 1 involves creating the abstract factory, toy gun factory, and step 2 involves applying the abstract factory to concrete factories, being the ABC and DEF pack factories. Step 3 is where we can now define the abstract product, being the toy gun. Finally, we take the interface and apply it to the A to F guns. Builder, as it says in the name, is focused on creating complex objects step by step. Builder separates the process of construction from the object's representation, letting the same method create different variations of the object. Applying Builder takes 3, optionally 4, steps. Creating the product class, creating the builder class, which will have the function to set the properties of the product, and adding a build method to the builder class, where the finalized object is made. You may also want to create a director class to control the building and choose the order of the construction. For example, let's say that in the toy gun factory, you want to create a singular gun type, but with different bullets, ammo, etc. Let's implement this with Builder. First, the toy gun class represents the product class, with different ammunition counts and bullet types. Then, the builder interface will build each of these properties. Afterwards, the concrete builder, which is the toy gun builder class, actually builds the toy gun. Finally, the toy gun director class actually constructs the gun in the specific order. Now you have an easily customizable gun builder, which can expand with more builders, like the A to F gun builders. A prototype pattern involves copying objects without being coupled to classes. It moves all the cloning code to the object being cloned. This design pattern is the simplest out of 5 to use, taking only 2 steps to apply, being creating the prototype interface for the clone function and the concrete prototype, which will be the object or product. Let's use the last example with the gun factory to show this. Here, our prototype interface toy gun will use the copy function from the copy module to clone an object, which will be the ammo gun class, which will also be the concrete prototype. Now we can create the ammo gun prototype and copy it as many times as we want. The final creational pattern is a singleton pattern. It makes sure that a class only has one instance and can be globally accessed. Applying the singleton method takes only 2 steps: declaring a static variable for the instance, and then creating a static method controlling how the instance is obtained. Make sure that the class's constructor is private. That is all the 5 creational patterns that you should know when dealing with object creation. Try one of these and see how easy and maintainable your code will be. As always, like and subscribe if you enjoyed this video and want to see more like this. Also, if you haven't noticed yet, I finally uploaded a teaser on my other channel, so check it out. And I'll see you in the next video.